Hi, I'm Eric Enno Tamm, the co-founder and CEO of ThisFish. I've titled my talk today, The Data Effect, How to Build Digital Seafood. So at ThisFish, our mission is really to drive profitability and sustainability with better data, basically digital, real-time, and actionable. And we do this by providing software and artificial intelligence to the seafood industry. Canada is a country that's built on the resource sector. Generations of Canadians were loggers, miners, and fishers. It's a story that I know really well because my father was actually an Estonian refugee who fled Estonia after the Russian invasion in the Second World War. And when he came to Canada, he basically worked in almost every natural resource sector. He was in fishing, forestry, mining, and hydroelectric. And by the late 1960s, he ended up in a fishing village on the west coast of Vancouver Island and became a fisherman and married the daughter of a local fisherman. So we really like to romanticize the seafood industry, that well-worn tale of the old man and the sea. It's a story that I obviously know very well, and there's some truth to that story, but it's equally true that seafood is the most globally traded protein on Earth. The industry is massive, global, and complex. Yet the information systems running supply chains are archaic. Most of the data is trapped on paper. It leads me to a joke about a poem I know, The Rime of the Ancient Mariner, basically data, data everywhere, but not a drop to sink. So all this paperwork creates enormous problems for business. It's inefficient, it's error-prone, which often leads to non-compliance, which is a big deal in the food sector. But it's not just bad for business, it's bad for the planet too. Seafood supply chains are some of the most notoriously opaque. Illegal fishing, seafood fraud, even human slavery. These are the problems that are plaguing the global industry. Most environmental and human rights groups are now calling for digitization and electronic traceability to improve the transparency of global seafood supply chains. But in an industry that is so large and complex, where do you start? There's literally millions of fishing vessels and farms on one side and millions of restaurants and retailers on the other. But in the middle, there's only about 50,000 seafood processors. This is the most critical node in the supply chain. It's the data bottleneck. So at ThisFish, what we've done is built new software called Tally that enables the seafood processing sector to digitize all their data in real time on the factory floor using IoT devices and tablet computers. We've effectively made smart manufacturing platform for the seafood sector with some of the most advanced technologies such as IoT, cloud computing, artificial intelligence, and advanced analytics. And why do companies buy our software? Well, our technology helps to reduce the cost of data management and collection. It improves process and inventory control and strengthens compliance with electronic traceability. We're basically helping to digitize this ancient industry. And we've proven that we can scale our technology across a very global, diverse market. From the largest lobster exporter in New Zealand to some of the biggest tuna canneries in Thailand and Ecuador. And what's going to drive technology in the future, like technology adoption in the seafood sector? Well, this is the Fish and Chips Index. And what it shows is that since 1990, the relative price of fish has gone up by 60%. Meanwhile, the cost of technology has gone down by about 50%. So this is the meta trend, rising protein prices and decreasing technology prices that I believe are going to help with technology adoption in the future. But it's not just the cost of technology, it's also regulatory market changes. Over the last 20 years, there's almost been 50 major market initiatives and regulatory changes that are calling for improved traceability. Just over a decade ago, the European Union instituted catch certificates, making it harder to bring illegal fish into Europe. That was followed by the United States. And then last year, Japan enacted a new law to strengthen traceability and the prevention of the importation of illegal catch into Japan. But we're not just trying to digitize the industry. What we ultimately want to do is generate new insights and new value from all the data that's been developed. So at ThisFish, we're really pioneering some of the most biggest advances in AI in the seafood processing sector. And we've developed an AI-enabled app, which we call TallyBot, that enables process automation and predictive analytics in seafood factories. And I'd like to consider Talibot a little bit like the R2-D2 of seafood processing. For those who are Star Wars fans, you'll know that R2 was an industrial automation droid that was built for basic mechanics and a computer backup system for spaceships. Well, in the same vein, we built Tally to be able to embed throughout the digital workflows of a seafood processor to perform all sorts of different types of tasks. So for instance, we can program Talibot with algorithms for automated quality control checks, verifying data, running advanced calculations, or even sending alerts to supervisors when things go wrong. We can also program Talibot with machine learning algorithms for predictive analytics. And we've also tried to give Talibot a personality with some color and facial expressions, because what we want to do is communicate to workers that Talibot should be seen as their digital helper, somebody that's really kind of helping them with their daily work. You know, I believe that there's going to be a lot of promise for AI in the seafood industry. And why is that? Well, there's lots of natural variability in seafood. And that makes predicting quality and production outcomes very, very challenging for seafood producers. So as you can see in this model, there are many variables, for instance, that impact yield in a factory. And in fact, too many for the human mind to comprehend. Well, that's actually a perfect problem for artificial intelligence. And in fact, what we have done is taken 3 years of production data from a tuna cannery in Bangkok and built a yield prediction model. We've also worked with a local salmon processor here in Vancouver to build a yield prediction model for the salmon industry as well. We're also working with a salmon processor in Vancouver on a computer vision project. We're basically taking video of salmon fillets as they pass along a conveyor belt, and then we're using a computer vision model to automatically classify those fillets according to their size, their color, and 7 different types of defects. And ultimately, what we want to do is be able to connect farm to factory to better understand what farm practices are leading to quality and production outcomes in seafood processing plants. You know, in many ways, Canadians are still loggers, miners, and fishers. Except we're logging into computers, mining Bitcoin, but hopefully most of us start sending out phishing emails. But all joking aside, a lot of politicians and some investors kind of like to dismiss the old resource sector as a bygone sector. But in a world of climate change, growing population, pandemic, and war that's causing supply chain disruptions and increased inflation, food security has become more critical than ever. And so you can't eat Bitcoin or an NFT, but you can eat seafood chowder, shrimp pasta, and smoked salmon, which is apparently what they're serving for lunch today at the conference. So thank you for listening and enjoy your seafood lunch.